So WorldMap is the beginning of an attempt to create a collaborative platform on the web. It's open source, so it's built from the stuff of the web, and because it's open source, it does open standards really well. WorldMap lets you organize big mapping data sets online. You can upload the stuff yourself, choose whether or not you want to share it, find the data that other people have uploaded already, play around with it, mash it up with your data, collaborate by finding other people's data and saying, hey, that's really cool data, do you have any more of it? Finding out, contacting them just using good old email. But also, we're modeling this a bit on Google Docs, so a map in WorldMap can be edited by many, whatever trusted group of people you might have could all be working on the same thing. And then we've got a number of ways to publish. Get your data out live or statically to just a few or the world. And all of these things, keep in mind, this is a very early platform. It evolved out of a project called Africa Map, but the beta version just rolled out in July. And so it's really in its early stages. All the things I just described are sort of, we feel they're just kind of becoming usable and really practical, but they still need refining and they still need feedback from people like you. So if you come to the front page, worldmap.harvard.edu, you can really do two things. You can create your own map from scratch, or you can look at maps that others have created. So I'm going to create a map from scratch and just quickly show you how. Creating a map from scratch gives you an open template. And we happen to be using Google Maps, but we could be using any backdrop. We're not locked into Google Maps. So I just clicked Create Add Layers, and I've got 3 ways to add layers. I just added a local layer that was on WorldMap. Now I'm pointing to a remote, now I'm uploading. All right. I've got a shapefile. In this case, it's this is a test slave trade route database. We've since completed this database, and soon we'll be uploading it to WorldMap. But I'm just sort of showing you how you can take stuff from your hard drive and with a few clicks put it up on the web in a way that you could share, integrate it with data that was already on the system. In this case, this is ethnographic groups. I'm just kind of showing you a couple things here very quickly to give you a glimpse. Feel free to ask questions. So now I'm going to actually view a map that already exists. I'm just going to go in and take a look at Africa Map and show you a couple things. To start with, I'm going to bring in a malaria propensity layer overlaid on top of population density. And now I'm pointing out to a remote server. This is World Health Organization server. I've got a URL to their web service, bringing back a list of all the layers on their server. And I'm choosing global health facilities because I want to see how those match up with my malaria data. Bang, I've got a live map. I'm pointing to their server in Geneva and bringing it in as if it's on my own. And it acts in many ways as if it is on my own machine. I can zoom in. And that's because everything we're serving to ourselves as a server. So it's a service-oriented architecture. So now I'm clicking on it, doing an identify, which actually gives me attributes back against that remote feature. And then because I've got my Google satellite, I can actually zoom right in and see, okay, that health facility is probably in this village. We released in July. We have had 850 registered users since then, 1,200 data layers, a fair number of them test layers, people figuring out how to use the system. Cut that in half, say, but 600 layers, a lot of them pretty full, 50 layers, 1,400 fields. These are basically collections. These are sort of like, you think of these as mapping portals people have created, portlets maybe. These are apps they've created. They've assembled layers data layers they care about and saved them, and they could share them with other people. We're now using WorldMap it's become part of several classes. We've got a list of about 22 that are considering use of WorldMap for spring. Our best guess is about 8 of them will end up using it, but who knows? Starting to prove itself useful in this situation. It's all open source. That's the stack. In a sense, WorldMap is a very heavily, you can think of it as a very heavily customized version of GeoNode, in which we've added a whole bunch of new features. GeoNode itself is a wrapper, a Python wrapper in a sense, written in Django, a Django wrapper for a whole bunch of really nice GIS components or modules that have evolved over the last 10 or 15 years. They're very robust, and they've all evolved kind of up together, so they talk to each other really well. And so we're standing on a lot of shoulders. And then down here we've got, well, this is actually the web client, OpenLayer. It's really kinky. Backend open source relational database, Postgres, plus GIS, so it's called PostGIS. And then really powerful translation libraries and projection libraries. And it's running, we're running it on Amazon on a single fairly beefy server, and we're, getting a fair bit of traffic, so five or 600, between 500 and 1,000 visits a day, each one averaging, a couple minutes. So a fair amount of, that translates into a lot of requests. And so far, so good. We're doing caching. We're trying to be smart about caching things as best we can. So any given view of any given layer on the system, if it's a WorldMap layer, never has to be generated again once you've generated it. So if somebody else comes back to a layer, so the first time you might look at a big data set, it might go ka-chunk, 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 ka-chunk as it loads. The second time it'll go bang because it's cached. WorldMap, so Django app here. We're actually doing web service connections to our own rendering engines here. GeoServer is a key rendering engine. There's our cache, GeoWeb cache, right? Files out to disk. And various forms of download, upload. These are our clients. We're hoping to, we've got ideas for a mobile client. Won't be terribly hard to do. We just haven't had time really. All of the data, any data that's in the system can be pumped out, can be downloaded in a variety of formats, can also be viewed in Google Earth. So interoperability is really important here. Uploads and downloads, and then also enables us to reach out to other organizations and bring their data in while allowing that organization to be the custodian, the steward of the data. They can update it, they can control symbology, we just view it. And of course give them credit for it, represent it as their data. So this web service model is really nice for encouraging groups to share data because they don't necessarily lose control over the data, and at the same time they get wider use of their data. This is a schematic to kind of attempt to convey this idea, and an idea for a vision, a goal of WorldMap, which is to improve the overall availability of GIS data by acknowledging that researchers need to have control, several levels of access control over their materials. In the beginning, they might not share it with anybody. Later on, they might be sharing their data with a small research group. Then once they publish their findings, if it's just a flip of a switch, then they might make their data open access, right? But if that data wasn't already in the system and they published, they have no incentive to go back and spend a bunch of work learning GIS so that they can get their data into some public system and they don't even know what that public system is. So, and the background argument here is there's tons of spatial data out there that we don't have access to. Most good spatial data is outside of Harvard. And how do you get it? Well, we're hoping that a useful system like WorldMap, which anybody can upload data to, will improve access to data for Harvard researchers. Here are some maps that have been recently created in WorldMap. These are collections of layers. Japan Map, Pluralism Project, China Map, Mapping Giza, and I'll just show a screenshot of a few of these. to the Japan Digital Archive developed by the Reischauer Institute. We're doing the place API for this. China map funded by the Fairbanks Center. Tons of really beautiful, great data here. In most of these map collections, these are data sets that don't exist anywhere else. Giza map, an early kind of an experiment in bringing together archaeological maps for one particular part of the world, the Giza pyramid. I'm sorry? So here we've got Google Satellite as a base map. We're overlaying a 1878 archaeological plan on top, and now we can zoom in or control transparency and look at how things have changed. Professor DeManuelian, who is our Egyptologist, has a ton of these maps now scanned in georeference, and is thinking about how he wants to make them available. This is a business cluster mapping demo that Wendy did. Philadelphia neighborhood map, World Fairs. I'm just give you a kind of an example of the variety of different kinds of map collections people are creating. Some recent features include a tool that lets you take any scanned map that you've created yourself or maybe you found online and upload it to this warp.worldmap.harvard.edu and georeference it online. And then, if you wish, include that in your WorldMap map. That's a pretty neat tool, starting to get a lot of use. Another thing we've developed is interoperability with the ArcGIS REST server, so we can bring in Esri's flavor of an open service. We have now tools, pretty powerful tools for taking all of the rich symbology that you can develop for a map in ArcGIS, ArcGIS 10, and pump that symbology straight into your map in WorldMap. So you have online styling tools in WorldMap, but they're relatively cumbersome compared to ArcGIS. A couple kind of fun things here. This one, Google Street View, I didn't realize, I kind of thought it was a bit of a toy when we did it, but a number of people have said it's really, really useful. So Google Street View lets you have your own data on the map for a city, European cities and U.S. cities mainly, wherever Google has Street View, and you see your data, and then you maybe have it be transparent with the roads behind it. Click, and you see what that space actually looks like. Now, doing that in Google Street View is cool, we all know, but when you've got your own, say, demographic data there, and you're clicking on that dark red polygon, you're wondering why the income is so different. You actually see the street. Sociologists are loving it. And we're working on tools to let you create layers in the browser, and we're also working on, with another group, to time animation of large temporal data sets. So we've got a number of really interesting challenges here. It's open to the world. We have a lot of layers, so we need to improve our search, both at the interface design level, but also we need to improve. We're going to need to improve search relevance, and so we're brainstorming now approaches for crowdsourcing the moderation of the content by allowing people to comment, rank, and message each other. Of course, system performance is going to be a challenge as the system includes more data and is getting more traffic. Maintaining quality of content and search relevance at the same time, maintaining performance is going to be the challenge. And these are some groups that we've received support from recently. This is on its docs and lists. And source code is available there.